Welcome to the OERA, hang on, this is going to be a fun day, the OERA Maturity Model, or why ORMs can be good for you. My name's Peter Judge. I work at Consultingwerk. I'll let everybody come in, the last few. Cool. I work at Consultingwerk. I'm a developer there. I'm a consultant there. I've been in the Progress world for a few years. Was working at Progress for almost 20 of those until a couple of years ago. I do mainly development stuff. That's what I like to do. Writing code is fun. Debugging code is more fun, maybe? I don't know. Debugging other people's code is even more fun. See, I'm a consultant. I'm smiling while I'm lying. You know, I've been doing this long enough. Nah, just kidding. So I've been around for some time. Again, I mainly code. I do a lot of PASOE stuff these days. So maybe I'll see you around when everybody panics at like the 28th of February next year, and they're like, ah. Yeah, so I work at Consultingwerk. We're a IT services consulting development company based in Cologne, or headquartered in Cologne. We do mainly OpenEdge stuff, some ancillary things, back-end, front-end. We have a framework called the Smart Component Library, which kind of is a bit of the genesis of this whole topic, of this whole talk. It's not going to be a commercial presentation, but we'll look at bits of it because otherwise I have to write a lot of code. Based in Cologne. I'm the US branch. We've got colleagues in Romania, in the UK, in the Netherlands. Where else? That's about all, I think. Germany, of course. Yeah, other Germans, more Germans. And customers around the world, except I think South America and Far East in Asia. So OpenEdge mainly, with some other skills. What's this slide? And some other skills. You will see various versions of this presentation if you come to my talks or to Mike Feshner's talk, so I will keep on going. Again, the other fun part of what we do, or a fair amount of it, is DevOps-y stuff, build pipelines, all of that sort of stuff, and it's interesting. It's interesting when you first put a build pipeline in place for somebody who hasn't had one, like the classical. You compile it with a desktop app, you've built your own compile.w, and you fill in the things, and you compile it, and then you copy all the files from there into the test server, and then they get magically propagated around the world. And you show them a build server with a Jenkins pipeline, and it's like, oh, that's nice. So, just fun. Okay, so today what are we going to talk about a bit? The OERA, what it is, what it represents. Not extensions, not snippets and templates, and not launching either, but mainly the OERA, and then kind of the maturity model that we've put on top of that. So, who's heard of the OERA? Most of you, good. Who's using the OERA? Kinda, sorta, yeah, exactly. And that's exactly why we're here. So this is from 2005, I think. Progress built and released the OERA. And they call it a blueprint. So they never said this is what you must do. It's just guidelines on how we think you should build applications. That's the original picture. There's a link to it. And it's just a guideline. So you can implement a piece of it, some pieces of it. You can implement it any which way you want to. Procedural, classes. Progress has, the first version was a procedural version, was a fairly complete example. I know that there are a fair number of companies that took that example, cut out all of the side bits and just plugged it in, right? And Progress never meant for it to be that way, but I know that that's happened. So people have a variety of implementations. In some years later, the pictures got updated and got renamed somewhat to the OpenEdge Application Architecture. The focus of that was more on this side over here, the deployment side, kind of how you run OERA-based applications in a PaaS server in your network. So they didn't really touch too much on, it's a bit small, but these pictures are pretty much the same as those pictures over there. They're just better marketing or better graphic designers. Yeah, but there's some links there that you can go and look and see a little bit more about Progress's view on how these things should all fit together. So with that, especially, since we see a lot of I want to make it squeak, aren't I? Since we see a lot of different implementations, we kind of were talking and working through this, and kind of came up, if you know me, if you know Mike, if you know us, we have opinions on things. And how should you implement the OERA was kind of the start of all of this. So the name of it is kind of based on, in HTTP world, is a thing called the Richardson Maturity Model, which is how you go from basically SOAP until the perfect HTTP stuff. And so this is kind of a take on that, if you will. So kind of starting from a bottom layer all the way up to what we think is good, or where you think you should go. And obviously people will do greater or lesser degrees of this. And again, it's just our opinionated approach on how you should be doing some of these things. Our goal really is, we know that Progress applications, OpenEdge applications, ABL applications are going to run for a very long time, right? There are people develop them, and then 10 years later, they're still like, we expect the ROI on this application, this R&D cost to be amortized over 10 years or more, right? How many of you have got applications that are less than 10 years old? Yeah, kind of. I mean, the other one is older than 10 years. Yeah, so 25 years, right? Everybody's got long-lived applications. And what's also become clearer, and you can see it from Progress's strategy, I guess, in the OpenEdge world, is that the UI is more your choice, right? You can use a Kendo front end, you can use an Angular one, you could use 4GL, you could use whatever, right? However you choose. And those change reasonably quickly, but we expect that the back-end code piece of application is still going to be the same for the next 10 years. The same, but things will obviously change, but generally stable on the back end. We expect there to be a PaaS-OE or a PaaS-OE-ish app server around for that amount of time. Does anybody guess how old PaaS-OE is? How long it's been released for? What year it was released in? 2005. It's already almost 10 years old. It's kind of crazy. Did anybody start working with it in 2005, 2006? Smart. It had some challenges back then. And classic app server as well. I mean, it's also 26 years old. Next year it'll be officially retired with 11.7 going away. So you can expect with a high degree of confidence that Progress will have an app server in the next 10, 15 years. And I'm sure that if PaaS ages out or gets deprecated, something new will come in to run the ABL backend code, and it will probably be compatible with the existing ABL. Right? We all know Progress does not deprecate anything, even when they maybe should deprecate some of the language, but hey. Yeah, so kind of this model was focused a little bit on that backend code running for the next 10 years, call it. Application modernization, so how do you go from something, and our starting point is something that runs on an app server is generally our start. How do you go from that into something better? Better would be a little cleaner, a little better separation of concerns, those kinds of things. Yeah. So our kind of, as I said, level 0, it runs on an app server. Does everybody have an app server backend? Most people? Almost everybody? This is also good enough, right? Something runs on the app server because then you've done some of the work of making sure you can run an app server, right? Context and blah, all of that sort of fun stuff. So our baseline with this was, well, let's start with it runs on an app server, because it's otherwise it becomes big. You know, how do you go from GUI to an app server or TTY. So you've got some app server, you've got some .ps that run on the app server, always .ps or usually .ps. If you're running with web handlers, then you're already a couple of steps beyond or along typically. And you've got clients, right? You've got pro data sets, you've got temp tables, you may be passing objects around to hold your data structures. I don't know if anybody's doing that, right? There was some people who moved into the world of, let's put everything in objects, right? We don't need temp tables anymore. But well, I'll get to that in a sec, or in a minute or five. Yeah. So basically, the lowest bar is if you've got some form of a service interface, right? Some form of a .p that you can call an app server. You're OERA compliant, right? You've made level 0, so that's good, right? So that's where we're starting from. The principles for what we think is important in terms of this model is firstly separation of concerns, or single responsibility principle, that a thing does one thing, right? It's hard to get there, but a thing does one thing. You don't have these massive classes, you don't have these massive persistent procedures that do everything, massive .ws that have everything in it. I mean, they're on an app server, but you have blobs of code, chunks of code that do what they are supposed to do. They do that well. And that buys you a bunch of things. It tends to buy you more code, more pieces of, more programs, more files. But you know, modern file systems are good at that. That's their job. But yeah, but generally where you go with single responsibility is if you give a developer, if you show a developer how to do one thing, they can do it repeatedly, right? It's a pattern in their mind. I'm not saying it's necessarily easy, and I'm not saying it's copy and paste. But if you say, if you want to retrieve data, this is the method you have to implement. This is what the signatures look like. This is what the payloads must look like. And then here's the bits you fill in, which is your application, your business. So those are the important things. Don't make them think about boilerplate frameworks, or not frameworks, but don't make them think about scaffolding and how stuff fits together. They should just expect that I put this code here, excuse me, and it does what I expect it to do. That's the goal of that. And you kind of wash, rinse, and repeat, right? You find a pattern, you implement the pattern, and then if you see exceptions to that, you take a look and see, well, is it a one-off exception? Because they always are, right? There's always that one program that is special and different and nobody ever wants to touch, because if you touch it, it will break the whole system, you know? But different patterns do emerge as you work your way through these kinds of implementations. As I say. So if you see more groups of things that are similar, well, then you put a new pattern in, and then the developers learn that pattern, and it kind of feeds on itself. One challenge with kind of implementing everything new, and this is the classic modernization, if you will, migration, upgrading, whatever thing, is we have a chunk of code in our application. We want to move it to a new style, if you will, a new pattern. Moving it there has a cost, because now the developers, now you basically breaking your code apart, right? So whatever this code is and does, you've got tests for it. Everybody's got tests for it. And even if the test is it runs in production and it works in production, that is a test. It's a common test. It's not an uncommon test, but it's a style of test, right? You know the code works. Moving it into new patterns for better code reuse or better isolation or separation of concerns means you've got to break that. Right? And so that can slow things down, because you've got tests that work here that may not work there, that you have to rewrite or that you have to redo. So you kind of have a little bit of that balance of, well, how much of the new do we take versus the risk of making changes that break things? Always a balance, right? And again, most development houses will, you have your own idea of that. Some code, like that sensitive piece of that .p that runs, you may not want to change that because you know it works and it's stable. So you have to find other ways of working with that. Yeah. The other reason to keep moving to a newer model might be you might have a lot of almost identical code floating around. So you might have validation routines or update routines, you know, order update, whatever, that are almost the same. 2 or 3 of them over the past 10, 20 years. There's been a couple made and they have one subtle difference in them. And so which one of those do you move into the new model? And how do you code that, right? And which one wins? Because there's always like a little if switch in the middle of the for each that depends on a special global variable that somebody set at the beginning of the .p, and now you've got to figure out how that gets into the code. But if you've got these multiples, one of the challenges with that on the other side is which one do the developers use? How do you know if you're going to use this update routine or that update routine, right? You usually go and ask the senior guy or the senior developer because they wrote one of the two of them, or one of the three of them, or one of the four of them, and they choose that one, or they tell you which one to do. But having an unambiguously named, unambiguously scoped thing means that it's easy to figure out which update routine to use because there's just one. You may be confused about the parameters, but you know what one to call. Sorry. The other thing we are quite opinionated about is use ABL, OOABL wherever you can. The compiler helps a lot, right? It helps you. One of the, not lies about OOABL, but one of the myths about it is that, or OO in general, is that it helps code reuse. Right? It doesn't really help code reuse. You can have good reusable code with procedural code just as easily. In my opinion, where the compiler helps is where it keeps you honest. You know what you can call, all of the strong typing stuff. It just helps in that regard. But as I said, take that and you combine that with the single responsibility principle or the separation of concerns, and we land with a whole bunch more programs, like many, many more programs. And that's manageable with tooling. But again, one of the good things about that is because they have one responsibility, they're not, if you make a change in one particular piece of code, it's not going to have a massive impact on the rest of your code base. Hopefully, that's the goal. Yeah. So that's kind of the guiding principle, right? Many people have got .p based backends, and that's fine. And you've got, it works. But OO does help you with some of these concerns. Interfaces, all of the kind of standard OO tools are very good for things like separation of concerns. Okay, so moving on to level 1. So you will see the theme of single responsibilities through a lot of this talk. But firstly, business services. So OERA calls them business entities. You might call them something else. I've heard them called many things with the word business in front and some kind of a description at the end. But they're your main unit of work in the application. So they are a logical data model plus behavior on that logical data model that may map directly to a database table. In our world, it's always a database table, right? But they may map to that. And making them as narrowly scoped as possible. So one of the themes is we can combine these later. So for instance, an order business entity shouldn't update the customer's last order date if there's a field like that in the database, right? There's going to be a separate service, a business task in OERA terms, which is going to say, I've got some order data, I've got an order to update, go update the order business entity, then go update the customer business entity to coordinate those things. It doesn't actually do the updates itself, but it coordinates the behavior across these individual units of work. I'm going to talk here about complex services have a bunch of distinct services. The complexity here is not necessarily not really what the code does. The complexity is that there might be multiples and the order in which they're called. Potentially transaction scoping over the top of them, right? So you may want to put a transaction around the update of the order and the customer record, because if one of them fails, if the customer record fails for some reason, the update fails, you want to back out the order as well. So things like that can be done in a business task. That's kind of the complexity and the orchestration, if you will, of those things go into that code. So a service API might look something like this. This is the CCS, it's a business entity interface, or two of them actually snippeted, right? One is a read one. So get data set is to get metadata, gets data, and gets how many records are in this count, right? So that's useful for having UIs where you know if you've got more data to go. And then an update one, right? And you can do a lot with those 3 or 4 methods, right? Not everything in a business service, but you can do a lot of fairly standard work, but it can be fairly complicated work to update an order record. ERP systems have heavy-duty code on orders, right? That's kind of their, or bills of material, or things like that. There's a lot of code behind that, but that can be behind these interfaces, right? So that would be your kind of service. Words are fun. So I say here, service interface, but it's an OOA interface, not a component, because there's a service interface component versus the service interface type. Service interfaces, their whole job in life is to understand what a client is asking and how it's asking, and translate that to call to a service. So you're usually going to have, they're also going to be fairly small in scope, and they're usually going to be tied to some kind of a front-end technology. So for instance, here's an ABL one. This is just taking the .p away, but it's got 2 inputs, 2 outputs, and it knows how to run that business service, right? This is very simple code. You can turn more of this into components, obviously, but basically run something, get the data, return the data set handle, right? Have a nice day. In this particular case, because it's an ABL client, we can just throw the error back. We know the ABL client on the calling side is capable of dealing with errors, right? Input parameters as well, right? Data set handle, an ABL client knows how to deal with that. If we look at a Webby one, that's a different kind of client, and so the code gets a little longer, and we have to deal with things slightly differently. So for instance, errors in this pseudocode get turned into a JSON object, right? We pretend that there's code behind, well, this one's actually not too bad. Get message 1, right? Whatever you want to put in there, you can pretty print it, or you can format it well or badly, however you want to do it. But a web browser doesn't know what to do with an ABL error that's thrown. Right? It's Tomcat or Pazoe is going to scream and shout and dump it into the logs and not do anything good. And that gives you a chance to deal with the client. Same with the data, right? We're going to add some data. Where do I do it? I didn't think I did it anywhere. There we go, sorry. Turn the data set into JSON, just standard JSON. Obviously you can enhance that with proper RESTful things, however you want to do it. But then this is how the client deals with it, right? So the path info, I'm pretending that the second parameter is the name of the business entity. That's also can be changed, right? But the point is that this web handler knows that if there's a get on a particular URL, it knows how to translate that into a call into a business entity or a business task or some business logic. And that's all it does. That's all it does in theory, right? Practice, there's always a lot of code behind a lot of these pieces here. There's lots of code on how do you map from a URL to which service to run, and how do you format the data that comes back, and all of those things. But the point is, this is specific to a web request. You're not going to run this code if you're running if you're running a ABL client. So that's the next separation. Okay, so now I will sit and make my head go backwards. But again, this is fairly basic, just as a, where did you go? Where did you go, friend? So again, just by way of example, kind of my snippet of code, this would be the code we'd run on the app server and get that back. And our web handler kind of looks the same. Business services, again, this is the CCS business service, the progress ships. It's a good example of a basic one. Their implementation does not really implement this. Progress has an implementation of a business entity which has its own slightly different API. And again, how you do that is less important than that you actually have a standard there. So orders or customers or all of these business entities flow through the same piece of code, right? So our implementation looks like this, and we have kind of our standard interface that gets implemented, which looks very similar to the CCS one I just showed you. And that's kind of the important part of this code. I'll come back to that a little later. Okay. So the second part is now where things diverge from or where some opinions come in, maybe more so. So the kind of OERA model has got layers for service interface, it's got layers for business tasks, it's got a layer for business data access, data source, and one of the big separations to do is to split that data access, data source piece out of the business entity. So the logical model is our business entity, right? It's got a, I'm just going to say, I'm going to assume it's going to have a temp table in it. 99.9% of the time, business entities have data set with temp table, one or more temp tables in it. And that is a nice logical model, right? So if you, for instance, representing the Sports 2000 sales rep table, right? It's got an array of extent 12, which holds the quotas or some number in it. I forget exactly what. Not all clients can deal with arrays, right? So we need to map that from, we'll have maybe, instead of having sales quota 1 to 12, we'll have January quota, February quota, March quota, and we need to map the database values in and out of that. So from a logical point of view, the developer's like, okay, January quota, that's easy. The database has it in extent 1 or extent 12. I don't know, maybe it does it backwards. Who knows with databases? Who knows with databases, right? So that's kind of that part. And the mapping of getting the data in and out, knowing where to read and write it, is a separate component, is this data access component. And its job is going to be, it knows where the data comes from, it knows where the data goes. I'm trying not to sing Cotton Eye Joe here, and I'm succeeding. But it knows how to do that. Having that as a separate component is really nice because it lets us do things like swap that out without changing basically the business logic interface, right? So for things like testing, unit testing. When people unit test, one of the big challenges with unit testing is what data am I starting with, right? Do I have to go build a whole new database? Do I have to populate it from a backup? Do I have to load a bunch of .ds to get it in a stable state? What happens if somebody else messes with the record I was expecting to be there? Now it's not there anymore, but now all my tests are going to fail because I have an expectation of that. Having a separatable data access layer means that you can now plug one in your test environment that doesn't read and write to the database, but reads and writes to an XML file, for instance. Because in your unit test, you're testing the business logic, you're not testing the read and write to the database. When you test the read and write to the database, that's a different set of constraints that you have. But this lets you componentize and your tests, make them smaller, and guarantee them, have a guaranteed set of inputs and outputs that you're going to test against. Yeah. Like I said, so as far as the business entity is concerned, it doesn't matter what the data access is. Again, it's going to talk to an interface of some sort. Maybe it's a .p, but no, it's not a .p, it's an interface, an ABL interface. Yeah, so kind of splitting that out. So if you've worked with data sets, kind of there's the data source handle. Would we call it a handle? Data source handle that you use to do some of that mapping. So in ABL, it's a separate piece already from the data set. And it should be in a separate class. The OERA defines 2 layers for this data access. One is a data access layer, one is a data source layer, and the differences between them and their responsibilities is a little vague. We don't think it's necessary to have another component just to match the boxes and lines on the OERA diagram. So service interface, business entities or business logic, data access is enough, and works well for us as well. Data access also has potential for doing things like multi-tenancy or application multi-tenancy. So instead of using the built-in progress multi-tenancy with a tenant where clause, it may add a company, a lot of pre-multi-tenancy database schemas will have a company column, which is company obj or whatever the identifier is, company GUID, whatever your identifier is. And every single query that goes to the database has to add that on because you don't want your customers to see data from a different table. Even if it's one physical customer, they may segregate their data logically. So data access is a way to do that. So you as the business entity programmer, you say, give me data, and the data access, when it goes and reads the database query, is going to add and company GUID equals whatever that value is, wherever that comes from. And you don't have to worry about it from the client side, right? You just say, give me the data for my current logged in user, and that gets added automatically. So that's a place for doing that, right? The business logic component doesn't need to know about that, doesn't need to write any of that, but it gets done automatically, as it were. Yeah. Okay, validation. Validation is fun. So I think until this point, most people are probably that have got a fairly robust or fairly stable OERA-based application will probably be around level 2, have separated out the business entities from the data access layers. If you started with the Progress business entities, you're not there. You'll have to still do that. Progress ships them as one layer together, the default one that gets built for you in Progress Developer Studio. So you have to split it out that way. The next thing to do, of course, is now validation, right? So sure, the client may give you the right data, maybe, if you're lucky. But always the back end is the gatekeeper to the data in the database. And so the business components need to do their own validation, verification that data is true, right? Or that is correct. If you do it twice, you do it twice. That's not the end of the world. And so things that you're going to check for, does a field have a value? Does a field have a value in a particular range, right? Can the, so whatever, if you're capturing people data, you want to make sure that the birth date is not in the future, something like that. Or some date's not in the future. Or you may want to make sure that the order date is not in the past. You can't backfill an order. Whatever the business logic says, whatever the business, the domain, the business says, those rules get applied through validation rules. Addresses is another one, right? So if your country is in the US, you must have a state. That's just the way that works. If you're in Germany or in Czechia, you may not necessarily have to put the province or the state in as an address thing because the zip code is unique enough. In the UK, for instance, the zip code takes you to your street. Well, postcode, sorry, not zip code. I inflict my Americanness on everybody. And so that's very common logic, right? You should only need to write that once. That small piece of logic that validates whether an address is correct or not. Different business entities, different data structures may or may not have an address, may or may not have more than one address. So an order might have a billing address and a shipping address, but a customer might have a billing address and a physical address and a head office address and 3 or 4 addresses that you need to validate. All of the rules for that validation are going to be identical between your orders, your customers, all of these different logics or logical services are going to be the same thing. And so we want to be able to reuse those chunks of logic because we're keeping with our single responsibility principle. Yeah. Yeah. I thought I had more to say there, but no. Cool. So, talked about this. I knew there was a more slide. Yeah. So again, kind of devolving it to that level is important. All right. So we can take a look at some. How am I doing on time? 11:05. Good. Good. So when we're looking at a business entity, here's the one I've just generated. Dun, 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 dun. Not you. but you. So this is a business entity I've generated from just not too long ago, but from Progress Developer Studio. It's the standard Progress one. And just starting from this point of view, right? There is a read and a create and an update, right? There are various methods like that. And so what we're going to want to do, and how this piece is structured, is obviously going to depend on the tooling you use, your standards, your frameworks, whatever. Right? But we're going to want to do some form of validation here, right? We want to validate, I don't know, that a business entity, validate that when, you love AI, don't you? Whatever, we'll just do the order date is not empty. I was going to say customer number, but right, is not empty. Now that's a very simple validation, right? We could just say if e order dot custom is equal to whatever, then no. Undo throw new app error needs a custom, right? Very simple. We could put that into a method in this class, right? Those sort of things. But we may also want to add additional validation on there. So we're going to add some form of validation. We're going to add a class in here, and we're going to say validate. We're going to say custom validator.cls, right? So we're going to add a validator here that knows how to validate a custom. So we don't care about the constructor. There we go. No, we don't want to do that. Right, so we've got a custom, right? So our first piece of logic we're going to have here is going to pretty much, where's our business entity gone? That piece, right? So we're going to have something like that, and we're going to say return false. So again, the decision of whether to throw an error from here or return a logical saying it passed or failed is a little up to the application. Generally, our guidance or our approach is if it's an assertion, it will throw an error if that condition fails. If it's a validation, it will tell you whether it passed or failed, and it's your responsibility to deal with that. So if the custom is not valid, I mean, we wouldn't call the method if we didn't want it to be valid, but that's okay. If the custom is not valid, then we may decide we want to throw an error or not. But you know, also, oopsie, we may also want to say something like, you know, if not e order custom, p custom. Let's say it's that, whatever, if length of PC custom, what is greater than 15, then whatever, return false, right? Because we have some business constraint on that. If, whatever, if not PC custom begins, whatever, ABC, then. So something along those lines, right? This is obviously going to be more complex depending on the application. So now we have a piece of code that knows how to validate a custom. But when we create an order, we may have other things we want to validate. So we're going to create another class called, I'll give it a different name, validate order, and that knows how to validate the whole order, rather than a whole order record, rather than just a piece of it. So just kind of layering it up a bit. So here we're going to say method public logical validate order or validate. No. And that's going to take, let's say that takes a buffer of an order record. this is now still quite tied to the business entity. Buffer PB order for E order. And why don't you like me? TT order. Naming conventions matter. Right, and in here we can now say, okay, what did we call you? Custom. And, you know, O, if not O, I'm not going to do the whole thing. Something like that. Why are you behaving yourself? Because it's not a string. Because it's not a string, Judge. There we go. Integer. Well, we'll do it as a string. Come back. Come back. Okay. And in here again, we may add validate address with billing address, validate address with whatever, right? And then the last piece, of course, from here is, oops, to put it into our business entity. Where were we? Order, create. So here we would say, whatever, define variable O, validate order as validate order, validate order. Validate, so whatever for each TT order. And that's going to be buffer TT order. And so if and here what we do here, we would go and add this, typically in our world, add it to the dataset's error string, flag the dataset as an error, blah, 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 blah. But you could throw an error here, right? So adding the validation here means we can kind of trickle it down. Validate order says that's a TT order buffer. We could pass in a handle in there. We could pass in an object representation of that with an interface. Buffers generally work, even if the names don't quite match, as long as the schemas match, Progress will be quite good about accepting them. Again, refactoring, we'll do that. Again, the next go around, we'll clean that up. But kind of the principle is, let's validate the row, and within the row, we're going to validate pieces of the row, right, against single concern. Yes, we're talking a bunch of calls, but now we know that that order number, this validate order number, custom validator, we can now use it for the orders when we create an order. We can use it when we create a customer. We can use it when we do whatever else we do. Create an invoice, right, for the customer. Now we want to make sure that's valid. So we get that kind of stack going. Cool. All right. Level 4, the fun one. So object models. Kind of related to what I just did there, where I passed the buffer into the order validator. I had to pass the whole thing in, and it just assumed everything is in there, right? Temp tables are great, and buffers as well, for many reasons, but they're handle-based. They have fields, and you will work with all of those fields at once. So you can't just work with a subset of the fields, right? How do you work with just a subset of them, right? If you've got fields that are ProgressLang objects in there, they're pretty much untyped, sorry. So you've got to do a bunch of work to cast stuff. You've got to know what the type of the thing is to cast it, and it becomes painful. So what our level 4 approach is to say, create object representations of these data models, of these temp tables, of these data sets. And this is where the fun comes in. These wrappers, or these representations, let's not call them wrappers now, but these representations don't replace the business services. They're another API into them that you can call from an ABL client, really, whether that's a PaaS OE session or a front-end session. In a way, there are developer enhancements, or they aim to improve the developer experience with how things should work. And you can do some fun things with that 4GL to extend the approach for building queries, for navigating with them. And so they're, in a sense, just syntactic sugar on top of these temp tables. So there's a number of choices of implementation. How many of you guys have, in your applications, played with replacing temp tables with objects or with classes? Was it fun? Sometimes. It's a tough choice, right? There's a couple of approaches you can take. You can do the wrapper approach. You can do a wrapper around the buff about the temp table. You can do a wrapper around the whole data set. You can do copying values backwards and forwards. You can copying the records backwards and forwards and then having a collection on them. These things are getting easier as Progress delivers more OO features. But the real fun thing here would be if Progress delivered the entity set that Rob was talking about yesterday. That would be really nice, but that's still coming. In general, my approach when we talk about replacing functionality in the ABL, or replicating it maybe is a better word, is to think about performance to a degree, or mainly. So the 4GL ABL is really good at working with data, right? For each is a very powerful tool, the indexing, all of that sort of stuff. If you've worked with ABL for some time, I think you'll appreciate that that's a really powerful thing. Those of us that have worked with this for more years are so used to it, we don't think about it anymore. But working with data, with those structures, especially in the data set world with the before imaging, that's, if you want to replicate that, and you can see on the front end sometimes, the JSDO does some of that, but it's a lot of work to make sure you do the tracking and the matching and all of that sort of stuff. So generally, we try to use the ABL as much as possible and improve it or enhance it where we can. And so these kind of models here tend to be that approach, right? Use the ABL wherever possible. We're not going to copy stuff around. Your mileage may vary. You may choose to do this. The ABL has become, again, a lot better. The lists, the generic lists and sets and maps that are in the 12.5 and up are a good choice for, can be a good choice for this. Serialization becomes a lot easier when you have objects because you're in more control over what gets written and passed across the wire, right? When you pass a data set as an output parameter across an app server boundary, you get what you get. Whatever Progress has decided to put into that format, or write JSON or write XML, that's what you get. It's not bad. I'm just saying you've got to balance a little bit the control you get versus the built-in functionality. And you may not care, but you may. We think that the wrapper approach is a good approach. So that's kind of our look at that. The other thing that's fun with these kind of approaches, and I say fun in the loosest possible term, is if you've got a big database or a reasonably sized database, building all of those objects out can be a lot of work. Generally, you'll end up writing some form of a generator from, yep, all the scars in the room. You'll end up writing a generator from something. And what that gives you is really nice if you've got the generator working, because now you can start using things like the auto completion in Progress Developer Studio or in VS Code to help you write queries to work against that data set that you were less likely to be able to do. You'd have to know more code, right? I've seen enough developers who, you know, colon space, colon control space, colon control space, colon control space. And that works because, you know, the IDE or the tool should tell you what you can do with this thing. It's harder to do that when you do, you know, tt.custom : right? What are you going to get there? You're going to get next sibling, you're going to get previous sibling, you're going to get what available, you're going to get some subset or some superset actually of handle-based attributes, and they may or may not apply. So, all right. So we'll take a look at some of that now. What I'm going to show you here is going to be code that's in our framework. And the reason for that is if we sit here and I code some form of a generator for you, we're going to be here a very long time. A lot of these classes and things, again, are best generated out. And so we have a class that we call, no, not that one, that we call a dataset model and a table model. So a table model kind of has a couple of parts. One is order table model, which is where you can code into, so your developers can write code in there, and a generated piece, which is generated, which they should not touch, right? OpenEdge makes it hard to work with code and figure out who's changed what where. So we kind of have the approach of generate everything out, and that's got a whole bunch of the fields, right? So we know that this include is going to go read a buffer handle, pull the value out, return it. This is going to do something similar and push it in. And what's nice now is when we code against this model, we can, if I create a new file, when we code against this file, we can get the benefits of which one are you going to take here? We're going to get the benefits of, not that one though, mod modules, sports 2000. We're going to get the benefit of the IDE helping us. Not that one. Not that one. Not that one. We have a couple of them. Like not that one. Those are all our tests. Not that one. Not that one. That one. There we go. There you go. That's the one. They're all the same, more or less. They just test slightly different things, and they're all just generated, and it's cheap to generate. Our testing approach tends to be, don't make the tests perfect. If you need to create a new thing that's a copy of something else and you change one line of code, just do that in the unit tests. Not in your application code, but in the unit tests. Just copy and paste is your friend. So what the dataset model will do broadly, thank you, AI, will instantiate an order business entity that sits behind it and work with that. The order business entity will have its own order data access class, right? That separation, it's got validation in it, all of the shiny bits and pieces. But working with the dataset model is nice because we can do fun things like we get the order completion, right? So the first thing is we know there's a customer in here, there's some other bits and pieces, but we can work with a customer here. And we want to add a filter because we want to only get certain customers, and now kind of the fields pop up, right? Again, this is, when I said syntactic sugar on top of a data set, this is stuff you are going to do in 4GL, like you can do it really easily. But generally, why this is nice is when you're talking about running queries across an app server boundary, you're passing a string generally. Some people have got query objects that pass a query apart and have got this whole object graph of a query and its predicates and the locks and the blah, 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 blah. Generally, you're going to pass a query string across. But so we can say, well, where whatever custom is less than or equal to 42. And we can add some data on there, right? So we can say, okay, now if we wanted to run that query up, I'm still copy paste. We're going to fill it, right? And again, these kind of things are whatever they are. No. And now if we say message, O dataset model is customer is available, and I assume it's available, and the name and the custom. Right. Okay, and if we now run this, it will work perfectly. No, it won't. Of course it won't. And if you can see at the bottom, in the middle, right, yes, and custom 1, right, that's always going to be the first one. And so, I knew it was going to happen. I'm just going to put it over there. And so why this is useful is, again, if you're used to working with a 4GL, why would I do that as opposed to writing for each TT customer where TT customer.custom is less than whatever? As I say, you can. This is just a consistent way of doing that, right? Not less than equal to, but with whatever. We can add stuff where country, and now this has different things. I don't want to do a list. I don't know. I don't know what the list is here. US. Right. It just gives us that query expressions and query. No, not is empty. Query. There was a thing here. Yeah. Query. Hello. Get questions. Add query expression. Query handle. Query expressions and always. Do I have it? I have it in my other little sample. What was it called? Query expressions, get expression. This is all great as long as the IDE is helping you. It's less great when it stops helping you. But that's life. Get expression. Right. So when you run this again, we've added 2 queries here. And it's going to build us a query, and it's going to try and find it with the business entity. Now that would run all the way through the business entity stuff, do the validation, do whatever, what's the word, enrichment of the data, and come back. Again, you can do this yourself, but having it in this kind of consistent model like this really makes life, I think, easier for the developer and consistent, right? You don't have to worry about where they're going to put the no lock on, right? That gets done by the business entity figures out where to do that, or the data access layer, to be honest, figures out where to do that. We are running a little short on time. Again, around the tooling, all of these kind of things, if I now show you where this class lives, and I'll just try and, for the order, you can see that one dataset model and all of the supporting stuff has got a fair amount of code that gets generated out. That's why you kind of have to go the generator route. You can, if you want to get the syntax checking, so for instance, the thing with the less than and equal to, I don't know if you noticed that on the dataset model, if I try to query the country, the choices I have here, where they're on that side, right, begins, can do, contains, equal to, less than, or greater to, but they are kind of strongly typed. If you're building a query string by hand, the odds of you making a mistake at least once is fairly good. Second time round, you're going to use a substitute or a quota or something to fix it. But kind of baked into a model, you can do this. Yeah. I don't think I have my. So that's kind of the. I left my slide out. So there's a very well-known quote from, I'm not sure where, but it goes something along the lines of ORMs, object relational models, are the Vietnam of computer programming. A guy phrased that some years ago because trying to map rows and columns, relational data into objects which have a somewhat different mentality, if you will, is really hard. It takes you a long time to do. And I think they were mainly talking about languages like Java or C#, you know, the ones which don't have the data baked into the whole language. You know, like Microsoft's done a better job with LINQ and some languages like that, but at that time it was really hard working with relational data in those languages. You had to do things like Hibernate as a fun layer. Did anybody have the pleasure of Hibernator in here? Yeah, only one. Lucky the rest of you. It's not fun, especially with both database, OpenEdge databases. But yeah, so the kind of point of all of that is when you get to that model, you land up with these multiple components that have single responsibility, separation of concerns, however you want to call it. You have a well-known programming interface. So for instance, if a developer comes along and works on a business entity, a dataset model that they don't know, they can use the tooling to help them figure out what's in there and how to operate against it. I'm old school enough to be like, I don't need that stuff. I know exactly what tables are where and whatever. But in reality, nobody has a whole view of a whole system, especially bigger systems. You know a piece of it, but not the rest. And so things like this can help you work with the whole system in a consistent model or a consistent approach. And I think that's the benefit of all of that. There's a white paper which is very similar to, which is much of what the presentation is at that QR code, or that QR code is that link. It's not steal your bank account, maybe. Hopefully. Yeah. And so that's that. Any questions? We have a minute or two for no, we got -2 minutes, but sorry, video. Yeah, but if anybody has any questions or comments, has anybody done some of these pieces? I suspect, well, certainly there's a couple of generators in the room that have gone down that path. Data access separation, validation separations, some nods. It's good. Yeah. So if you want to discuss it or have questions or comments, I'll be here for a couple of minutes more. Our booth is just literally around the corner. Yeah, and I say thank you for your time. Okay.